Hi guys, this is Miss Eisencraft, and today we're going to take a closer look at vertex form, one of the forms we talked about last week with the quadratic equation. If we go to some of our notes from last week, uh, I went over how three common forms we'll see quadratic equations written in is standard form, vertex form, and factors. So we're going to really focus in on vertex form today, this week, and see what the numbers in the equation can tell us about its key features, because we're going to graph from it. So what I'm going to do is I'm going to show you a Desmos graph, because I think this is really great, and then we'll go back to the notes. So Desmos already had this all set up, and if you look here, this says parabolas vertex form, and what we have is basically they have some sliders, because A, H, and K, if you remember, are numbers. So if A was 1, H was 0, and K was 0, we would have the parent function, what Mr. Chalman showed us the other day, which is a parabola centered at 0, 0. Okay. But what's nice about vertex form is we know the we know that the parabola can shift around, and sometimes it even can get narrow or wide. So we're going to look at what numbers would tell us information about our parabola. So let's start with H. Okay, so H is the number inside the parentheses, and let's just push play and let's see what would happen if this number changed and is like 1, 2, or -1, -2. Let's see what happens. As you can see, it moves to the right and to the left. Okay, interesting. Okay, so for example here, when H was 5, instead of being over here at 0, 0, it's over here at 5, 0. And when H was -5, it's over here at, so if H was -5, it would be over here at -5 instead of here at 0, 0. So it appears as though changing the H value all it does is change the parabola, slides it or transforms it left and right. Okay. Notice the parabola is not changing shape, it's just moving or transforming. Okay. So let's go back to 0. Oopsie. Okay. Now, let's go to our K value. Our K value, if you look, it's having it go transforming up and down. It's going off our screen a little bit. Let's see if there we go. Up and down. Interesting. Okay, so let's stop. So when you have a K value of -2, oh my gosh, it's down 2. When you have a K value of +2, it's up 2. Okay. Now let's take a look at the A value. And we're really going to focus this week when we're graphing. All the A values are going to be +1 or -1. Let's first of all see what happens if we change the A value to a negative. Boom, goes upside down. And if we change the actual number, let's say we change it to 2, it actually is going to get, let's actually watch, narrower. And just to throw some vocab out there, they actually call that a vertical stretch. And when it gets wider, they call it a compression. So you're kind of analyzing it from its height. So we can use the words narrow and wider, but you'll also hear the words vertical stretch or compress. And that's a little bit, we'll talk about that next week. Okay, so finally, let's go back to A as 1, because when we graph this week, we're going to keep A being 1 or -1 this week. The last thing I want to show you is this is called vertex form, because when the parabola moves left, right, or up or down, these H and K values tell you the vertex. So if you go here, and if we push play here and push play here, both of them, the parabola's vertex is always the h and the k value. So you can kind of center your parabola. The other piece is the axis of symmetry. So if I go, the axis of symmetry is a line that cuts the parabola in half. So if I'm going to want to know what the axis of symmetry is, the nice thing is it always goes through the vertex or goes through the x value of the vertex, which is our h value. So if I just say x equals h, whenever h moves, let me change this to a dotted line. Okay, done. So as we move these, the axis of symmetry stays with it. And the axis of symmetry, let me just pause, boink. If you look, the axis of symmetry is always the h value. Okay, so what I'm going to do is we're going to go to our notes now. And I can toggle back to Desmos if you'd like, but we're just going to have this as a reference, and this will be really great to keep referring back to when you're graphing. Okay, so we know the a value, and we talked about this just briefly with the notes last week. The a value in vertex form tells you if it goes up or down, and it also has something to do with the width. So I'm just going to say a is if it's positive, it opens up. And if it's negative, it opens down. And it also tell you how narrow and wide. So it will say, let's just say describes the width. And again, today, because we're trying to break it down, or this week, the a value, we're going to keep it at 1 or -1. So you don't, we can just really get the pattern of typical parabolas down. Okay, h is the left-right action, and you need to know that it has a minus here. So when it says -3, the h value is +3, and so it is going 3 to the right. And if it says +3, it's moving 3 to the left because it must be subtracting a -3. So it's a little bit weird with the sign here. But anyway, the h value tells you how much it moves right or left. So if it says minus, it in fact is moving it to the right because there's a minus in the equation. And if it says plus a number, it's moving it that many units to the left. And again, we can always think of the parent function. It's typically centered at 0, 0, and so it's moving it right or left from 0, 0. Finally, the k value tells you how much up or down. And since the equation has a plus sign in front of k, it's what we would think it would be. Plus means whatever number this is, that's how much it moves up. And minus would be how much it moves down. And because quadratics, you can't, like a line, just find 2 points and make your line. You have to, it's symmetrical. So a vertex is really helpful because if you know the middle, you can then graph much easier. Vertex form is great because it tells you that really significant anchor point of which, for the parabola. So the vertex is always, let's make this, I don't know what color. The vertex is always H, K. So whatever number this is, whatever number this is. Okay. And the axis of symmetry will always be x equals, remember it's a vertical line, and it will always go through this number of the vertex. All right, now at first this can seem a little bit weird because we're just using letters and not numbers, but as Ms. Austin goes through some examples, it will come back to this and it will keep making a whole lot of sense. And again, we're just using transformations of like the parent function that Mr. Chalman used you last week. How much does it move left, right, up or down? And graphing quadratics is kind of fun. Okay, Good luck, everybody.